Hey, what's up guys, welcome to Developer. In this video we are going to be implementing DFAs. Before starting this video, I would just like to say that this video contains chapters, so you can jump to the part which you want to see. So, carrying on from what I explained in the last video, we discussed a little on what we are going to be implementing, how that is going to be implemented, the low level details of it, and now with that explanation out of the way, let's quickly in our include directory create a state.h. We will quickly declare the header guards hash if and def state h hash define state h. So let's declare our state struct state type def requires a name, put it over there. Let's look at what our state needs to store. So a state needs to know the information whether it's an accepting state or not, marked by these double circles. So we need to know if our state is an accepting or not, is an accepting state or rather a rejecting state. And we also need to know the transition function. So given an input from our input alphabets A, B, 0, 1, whatever, what is the destination state we are looking to move to given this input. So we need to have two things. First is going to be our information regarding is accepting or not. The second thing is going to be the transition function itself. So let's quickly have that first information. We'll have the information if it's accepting or not. We'll store it in a bool is accepting, and we need to obviously it doesn't know what type bool is. Yeah, so we need this information about the transition function too. Well, let's first think about how we'll have the transition function as part of our state over here. We can't define functions inside of structs. Since it's C, we cannot declare methods or which are basically functions inside structs or classes like C++. So we need to find a workaround over here. We basically can store variables inside of struct. Here we can store a variable, store some sort of reference to our function, which is a function pointer. So we will have a variable which will be a pointer to a function. Make sure to check out my video on function pointers if any of this sounds unfamiliar territory to you, and this will be very easily understood. So I'll highly recommend to go and watch that video before coming back to this one. So pause this, go back to that video, see the function pointers I've put in chapters. You can quickly go and see where C function pointers are discussed. So I've discussed them in some detail. Let's first look at the function signature we are aiming to have. So we will have transition function returning as a state pointer function, and what we need to take as input will be a char. So we'll take a character as an input, a, b, whatever, and that transition function is going to return us a pointer to the next state. Okay, so what a transition function is going to be looking like. So a transition function would be returning a struct state pointer. Since we're declaring the struct state pointer inside of the struct itself, before the type def actually gets initialized, we need to refer it with the struct keyword. We need to name our function pointer. What we'll be naming it, let's name it transition function. I don't have any better ideas at the moment. Transition function, and let's get on with it. The transition function would be taking in a char input. It seems good, it seems fine, it seems nice. This is our state, this is where we are. Okay, let's quickly create dfa-h, and within dfa-h we will be again creating our header guards hash if and def dfa-h hash define dfa-h. Okay, now we need to again type def. We also need to be including the state h header file because DFA will own states. Type def DFA, and we will have an array of states. Since we can't create an array like state states and num states where this is a variable, this goes against the C standard. We can't have it like this, const int num states. We cannot have it like this. Store a state pointer and the number of states. What we'll be doing is we will be having a pointer to the very first item in the states array, and the number of states will help us not overflow the array when we iterate over it, while we are going to be iterating over it for running our DFA string matching. Okay, so DFA has states. Let's also store the information of what the current state is, because that we'll need to know at the end when the DFA loop ends, string matching loop ends. We need to know if the current state has that accepting state bool set to true. So there's, for example, if we have the run or match function and we take in a string, which will be a constant pointer, we want to be doing a lot of stuff in it, but at the end we need to check if DFA current state, I'm just writing pseudocode over here, is is accepting something like this, and we need to return this. So if this is true, then we match, else we do not. So we need to store the state, current state information. We need to store how many states we have, and we also need to have some initializer for our DFA. Let's have a bool. So what we're trying to declare over here is a function, rather function pointer, a pointer to another function, which will store the string matching implementation, which will iterate over the states depending on what the um, input it gets at every stage and the next stage. So we'll basically traversing a directed graph DFA, and based on the input whichever we receive from our input string, we finally will conclude if the final state is accepting or a rejecting state. So we will create this function pointer. The reason why we are creating this is a function pointer is like we want something like this to work, dfa.run or dfa.match. We want this kind of syntax. This kind of syntax means that we will be calling the match function, or the match method rather, and since C does not support methods inside of structs, that's something which C++ does, we can't call this unless this match happens to be a function pointer. And the reason as to why we are doing this, because it's readable and it also mingles well with how we have this transition function as part of the state. So we can call this match string, and we'll take in a const pointer for our string, and it will return a boolean. Yeah, that looks fine to me. Let's have our implementation for dfa.h in dfa-c. Let me split the screen so that we can see the implementation as well as the interface, the dfa-h header file. We'll quickly include dfa.h, and we will define our function. The function which actually it will be pointing to is going to be this one. So we can't have two symbols with the same name. Let's prefix it with dfa underscore, and the const pointer goes in over here as the string. We'll have our okay. So well, this function, if we are declaring it, if we are defining it and we aim to be using it, then we need to declare the function first in the header file. dfa match string const pointer. We'll also create a construct function which will return nothing, and will be just constructing construct dfa, where we'll be taking in the number of states. Well, let's keep it constant for now. We'll be taking the state pointer, and we will also be taking in the pointer to the initial state. Within this construct DFA, we'll actually be binding this match string function pointer to the DFA match string. Okay, let's implement DFA match string for now. Let's have our string length for the string which we have gotten to match. Const size t length equals sterling string. Now we can call to declare derivative function. Okay, we will include this. Now let's go on to the next part. For size t I equals 0, I less than length I plus plus, what we are going to do is ask the DFA. So we need to have the DFA somehow over here. Also pass in the DFA pointer to the DFA match string function. Also, we need to have the DFA pointer in the construct DFA because we need to know the DFA which we are trying to initialize. Well, this uh, is very familiar syntax to me. Let me quickly jump over here and show you what I'm going to name this. Then you might have some flashbacks if you have already done some object-oriented programming. So we will be calling this the this pointer. So as you might already know if you have worked with programming languages other than C, so you might be knowing that all non-static functions, the methods, they have a this pointer passed to them by default. What happens behind the scenes is that the compiler passes the pointer to the object for which that method is to the function signature. We don't need to provide this since this is a repetitive task, so the compiler does it for you. Every method which you declare, you need to pass on that pointer to that particular type, and that variable, that actual pointer, is known as this. This is what this is. So we will need to know what the current state is. So where we are in the DFA at this moment, the current state would be this current state. This is the current state of the DFA. We also need to know the destination state. The destination state can be known by running the transition function on our current state. So let's first also have our alphabet over here, or the input. We have input as string of I. This is our input. Let's name it input character. We pass on this input character to the transition function of the current state. So current state is a pointer to a state, and we call the transition function with the current state. As you might have already realized with the input character. Oh, we also need to have the type, which will be a char. As you might have already realized, the transition function 2 is very similar to the math string, as both are the function pointers. And yeah, well, we need to pass in the pointer to DFA because what we did was change the signature a bit. DFA pointer this becomes the first parameter to the DFA matchstring function, and matchstring function takes in a DFA. Well, this is going to be a struct. Let's quickly move on to the state, and we also need to have a struct state pointer state declared as a parameter here too. So what we need to do over here is pass on the current state as the first parameter. This all looks good. This is our destination state. We also have a reference to a pointer rather to our destination state. Once we have our destination state evaluated by the transition function, we'll point our DFA to move to this destination state which the transition function just evaluated. So what we'll be doing is we will change the current state to be the destination state. Now at the end, we just have to return this current state is accepting, whether this state is accepting or not. If the state is an accepting state, then we know that the DFA has matched our string and we return true. If this state is a non-accepting state, we know that we haven't matched the string and we return false. Are we missing anything? Let me quickly go over and see if we are missing anything indeed. Yeah, we are missing construct DFA implementation. So let's quickly implement that. Construct DFA, which will take in a DFA pointer. Call this const int num states state pointer states, which will be an array of states, state pointer current state. Or since it is constructing the DFA, the current state happens to be the initial state. So let's call it like that. It will be more clear. Let's initialize everything. Are we having any issues? Cannot assign to non-static data member. Num states with const qualifiers. Okay, do away with the const qualifier because once DFA is constructed, we can't modify the value for num states. That's probably fine because this is not a proper constructor. If this was something like C++, then you would have initialized this in the member initializer list, so it doesn't matter if it's const or not. you would have been able to initialize that. Now we have constructed our DFA. Well, something says to me that we do not need to have this state array at all, or these num states, because what we are essentially doing over here is running this DFA match string function, and we just need the start, which will be the current state of our DFA, and within basically every state itself contains the information to move to the next state. So we never in the DFA need to know how many states will we have actually. Let's simplify this a bit, remove these two variables. We only have the current state, and we, well, simplify our construct DFA as well. This goes away. Construct DFA now takes in only one single state pointer. We need to get rid of this in the implementation too. Well, now this looks fine. Okay, let's quickly jump over to the implementation part. We'll get rid of this. We'll include DFA. Well, let's import it before anything else. We'll have our DFA, and we need to construct DFA, where we provide the pointer to the DFA and the pointer to an initial state. Well, this, let's keep it null for now because we haven't yet created our states yet. So let's create our states as global variables for now. Let's create state q0, q1. Well, what is the DFA we are implementing? So this is the first DFA we are trying to implement. This is the one which we are trying to implement. Okay, state q1, q0 and q1. Let's define our state parameters. Okay, so let's quickly jump into the state h header file because we have some garbage over here. We need to clean it. So looking at the state header file, we only need to define whether if it is an accepting state or rejecting state, which we can do as such. Is accepting equals true, is accepting equals false. Q0 is the accepting state, it's marked with 2 circles, and Q1 is the rejecting state. That's what we have done. Now what we need to do is create our transition function. The transition function for Q0 is we are going to be call it and get Q0 transition function. It is going to be turning me a state pointer, and it is going to be taking in an input of a character. Well, it also needs to know the state information, that this pointer, well, let's first call this state, which is basically the pointer to the Q0 state only. We will perform our transition logic in this function. Input equals a. Well, then we can stay on the current state itself, return state or return address of Q0. This will be more clear. Else, in case we do not receive the input A, we can return Q1, address of Q1. So as you can see, we receive A, we stay on Q0, we get B, and we go to Q1. Well, DFAs have a set of input symbols, so if the set of input symbols in your case is A and B, so telling if not A implicitly implies that you are calling it B. That's our Q0 transition function out of the way. Now let's quickly write the Q1 transition function. Q1 transition function. Again, we'll take in a state pointer, char input, and we'll see, well, do we need to even see anything? We know that whatever the input symbol we get, we just stay on Q1, address of Q1 regardless. And now we can call, or we can assign the transition functions over here. Q0 dot transition function is Q0 transition function. Again, Q1 transition function is Q1 transition function. Now what we can do is DFA dot match string. We also need to define the first state. It will be Q0. So we'll start at Q0. The strings which we can match. So as you might remember, the first DFA which we have over here, it matches strings which contains only A. So if there is anything other than A, it rejects. So what we can do here is we also definitely need to provide the pointer to DFA. Let's store this output over here and just log to the console, please. Accept it, reject it. So let's quickly run this program, see if it actually works. Build and run. Oh, we get a SegFault. Let's quickly see where we are doing things wrong. Or put in a breakpoint over here, construct DFA and launch file. Step into this construct DFA. We initialize the current state with the initial state, and we never actually map the transition logic. Or well, let's quit this debug session, fix this. The DFA header match string. So we never actually specified the match string over here. It is going to be DFA match string. I hope the parameters are all right. They are. We can close this, move to main.c, build and run it again. As you can see, we get accepted. So our string is accepted. Let's change our input to, well, let's have B for this character. Let's build and run again. Now this time the string gets rejected. Okay, so we successfully have made DFA implementation. Now let's use this library sort of which we have over here to model this DFA where Q0 is not the accepting state anymore, Q1 is, and the transition functions have also changed around a bit. I'll flip this over. The Q0 transition function also changes. We stay on Q0 if the input is B, and if it's A, we go to Q1. So if it's A, we go to Q1, and else we stay on Q0. This is the only change which we need to do over here. And the Q1 transition function, we stay on Q1 if it's A, and we go back to Q0 if it's B. So we need to change this a bit. Let me expand this. So if input is A, Q1 on input A goes to Q1, return Q1, else the input would be B and we go to Q1, Q0 and we go to Q0. This should work. So what this DFA does is it accepts every string which ends with A. This string which we have over here, this should be accepted if we run this DFA on it. So let's quickly run this. We should expect accepted, and it is indeed accepted. Let's delete the last two A's over here. Now we are ending in B. We should expect rejected, and we get rejected. We can put any number of A's, doesn't matter. The last character is B. Our DFA rejected the string once again. Just put an A at the end, this A, and our DFA would accept our string. So, such a simple implementation. We had created only two header files and two C files. Well, one being the bare minimum main.c to contain the main application, and one dfa.c to contain the implementation of dfa-h. One note or information over here, actually we need to see state to be as an interface. So for those who are familiar with what interfaces are, coming from some managed languages like Java and C#, what interfaces are actually, they denote a set of functions and variables, most likely functions only, which are exposed by a particular type. So every state needs to have this transition function. So what a state exposes is this transition function method, and what this transition function does is to be implemented by the implementers who sort of inherit or implement the interface. The transition function implementation is something which the state is not concerned with. Every child or the class which is implementing the state interface would have to concern itself with the logic for implementing the transition function. Q0 in our case could have simply been, if we weren't doing it in C, Q0 would have been a class which were implementing state, and it would have its transition function as such. So what we have done over here is something which signifies object-oriented programming, calling methods on objects kind of behavior in our DFA and state as well going on. This actually is a very popular strategy of implementing object-oriented programming in C, and some large code bases you might find this to be the case. So in this video, we not only went over how we implement DFAs, we also got a flavor of what quote-unquote object-oriented programming in C could look like. With that said, I'll end this video. I hope you learned something new from it. If you did, make sure to like this video. If you have not yet subscribed to the channel, Make sure you subscribe to see more video of this nature in the future. I'll see you in the next video. Till then, keep on learning, keep on growing. Bye bye.